Hi everyone, it's great to be part of Splunk.com and thanks for joining our session. In this session, we are going to talk about building very large scale smart stores. But before we start talking about all the details, I just want to say a few words about myself. My name is Ugur Tigli and I am the CTO at Minlo. Minlo is an object storage company, software-based object storage company that is high performance. And before joining Minlo about 3 years ago, I was running infrastructure engineering at Bank of America. And at Bank of America, I was responsible for both design in storage as well as compute. So I had some experience building very large scale deployments, and it's been quite helpful at Minlo when I'm working with customers, trying to guide them and point out a few things that I learned in my past experience, which included building multiple cloud implementations, private cloud implementations, as well as supporting different infrastructures. Today, in this session, we have a very brief agenda. We're going to be talking about infrastructure as a software trend in the industry, what it means for building a large-scale deployment using Splunk software together with Minlo. We're going to talk about something called disaggregation principle, or disaggregation of storage and compute. I'll get into some of the details and how it is very helpful when you disaggregate compute and storage in building very large-scale deployments. We're going to talk about Box, which is one of the largest content sharing companies in the world, how they turn to Minlo technology to deploy a very large scale SmartStore deployment, which is probably the largest in existence that we know of, and why Minlo in general as an object storage software solution, and when put together with Splunk SmartStore technology, how it can help customers building a very large scale deployment and having high performance, but at the same time also achieving low cost when building these infrastructures. Also, we're going to talk about a few things that are very specific to Minlo software, which is active-active replication. We'll get into details, and we're going to summarize with a few takeaways and what you guys can do right after this session to use Minlo technology jointly together with Splunk SmartStore. With that, let's start with infrastructure as a software. Infrastructure as a software has been a trend in the infrastructure implementations for about probably 6 to 8 years, I would say, that I kind of remember, and I remember working on it from probably 2013 onwards in my old job. And what drive infrastructure as a software as the solution for hyperscalers first and large enterprises afterwards is because simplicity scales. When you have a simple solution that is not hardware based, appliance based, built only for specifically for one thing, it's really hard to scale those solutions. Even though they can scale within its hardware constraints, you cannot really scale them across the data center. So hyperscalers recognize that, so they try to go into building blocks, simple building blocks, and build things that are simple as a building block, and when you repeat them a lot, then you can achieve very large scale deployments. The simplicity scales very well. Hardware becomes the commodity. This trend started with appliance-based infrastructure solutions, first with specific databases to storage solutions, then to network. This trend has been out there, and software-defined solutions are today's standard. It wasn't the standard perhaps 5-6 years ago, but today it's a common infrastructure phenomenon that everybody is using a software-based solution because it's easier to design a commodity server and build different personas on top of it and deploy them into a data center to solve various problems. So that dynamic allowed hardware, commodity hardware to become the building blocks. And of course, the economics plays a big part in it as well, but having the flexibility has always been very important to builders of large scale data centers and private cloud implementations. And the final thing is API and automation. In order to do API, you have to have, in order to do automation, you need to have APIs. And these two concepts goes hand in hand. And because of the automation needs when you make commodity hardware and software deployments, you need to have APIs, both from an access protocol perspective, like S3 APIs, providing a standard API to access your object storage, or from a management of the components in the infrastructure, whether it's network configuration or storage configuration. This became a de facto standard in the industry, essentially. So these trends together made infrastructure as a software a reality for today's data centers, and all large enterprises either have a program going into fully software only solutions in their data centers, or they are trying to convert their appliance based solutions into software only because of these benefits that they get eventually. Talking about disaggregation, we have this same principle. We saw it when Box turned to Min.io and used Min.io together with SmartStore to solve these problems that they had. One of them was scale. I'm not an expert in Splunk, but as everybody can talk about the high level indexers as well as storage going together is not an ideal solution when you grow up to 100 petabyte, 200 petabyte type of a solution. In any solution, not only Splunk, when you have storage and compute together, it's not a good idea to have them grow together, because one of the storage demands can be more, compute demand can be less. Hadoop is a great example of this. It's proven to be wrong in many cases where you scale compute and storage together. One of those resources will be not used as much. And in my experience, I've dealt with many Hadoop infrastructures. Most of the compute utilizations in those infrastructures were about 3-4%, whereas storage was heavily used. Because of the same concern at Box, they also looked at SmartStore as a way to have, when they ingest multiple terabytes per day, they figure out that that can grow into multiple petabytes per quarter, and they needed to have a solution where they separate the compute, the indexing power from the storage, and they came to Min.io as a solution. When using SmartStore, you can separate the two and build a larger, more economic solution at the end. Second point is economics. A classic aggregated approach, it simply just doesn't make sense, as I mentioned. Just having compute and storage, two resources that are controlled and demanded differently, is not a solution at large scale deployments, and it's never going to you can satisfy one but not the other. And the performance is very important as well in most of these cases. And what happened in Box's case, they needed performance and they wanted to use hard drives. And the hard drives, rather than SSDs, they wanted to use HDDs, and they wanted the HDDs to perform as good, not nearly the same as SSDs, but an aggregate when you put them together, they wanted high performance. And Min.io can provide that, because we do a few things that I'm going to get into details in later slides, how we differentiate ourselves as an object storage software by using hardware, the chips and registers to do these calculations at a very high speed. And also from a network perspective too, having this type of an approach, a disaggregated approach, allows you to reach higher performance compared to a hardware-based approach or a aggregated-based approach where you put things together and not separate storage and compute. So, talking about the largest SmartStore that we know of at Box, we have a few details here just to give you a scale, understand how Minio can be used in a large scale deployment. In their case, they were aiming for a usable capacity of 38-40 petabytes range. In order to achieve that, they used 50 petabytes of raw hard disk space. And when you use erasure code setting of 12.4, meaning 4 parity and 12 for data, erasure coding is simply how object storage software chops data into pieces for HA, high availability, and data protection. Some of you may be familiar with RAID in file system or in SAN world. RAID is a way of achieving the same outcome. In object storage, it's called erasure coding, and you can have different data and parity configurations depending on the yield that you want to get from a usable storage perspective. At Box, they use 16 nodes, and very different than many other implementations we see in the industry. They heavily put the large amount of disk into each node. In their case, they put about 216 terabyte disk. They were very large scale from a JBOD perspective, amount of storage they put against one of these nodes. And in terms of network, they chose to use 2 times 25 gigabit network. In most of the Minio deployments, whether it's SmartStore in general, we always ask for making sure that you have enough capacity on the network, because we are not CPU or memory bound. We are very heavily bound for bound to network, as well as the PCI lanes that are providing number of disk, and PCI lanes that are providing the throughput from that system. So that was a specific example for one implementation, a large-scale deployment of a SmartStore working together with Minio object storage. When we look at granular, detailed architecture of other customers, they have the same kind of implementations, but this picture just talking about a very generic Splunk implementation working together with Minio object storage. The details, I'm not going to go into the Splunk details. I'm sure most of you are very familiar with that. But essentially, a set of indexer servers establishing an indexer cluster. If you want to use SSD storage within that, it's totally fine. But in Box's case, as I mentioned, HDD's hard disk drive, the splitting disk drives, is also capable of providing enough performance for most implementation, most use cases. We suggest at least a 4-node implementation from a Minio object storage perspective, and we like to see 25 gigabit network for HDD, and we can easily saturate a 100 gigabit network for SSDs, so you can get a lot more performance or throughput from that perspective. So Splunk SmartStore has the concept of hot and warm storage in essentially, but using Minio object storage, you can get near to hot and hot type of implementation. And I'll get into some of the details in a bit, why Minio can provide better than many other SmartStore integration software solutions out there. But before going into that, I just want to talk a bit about Minio's differentiation compared to other object storage software or hardware-based object storage solutions out in the industry. Minio has been established in 2014, and our CEO and co-founder A.B. Perisamy and the core engineering team comes from a file system, distributed file system background, and their previous company was Gloucester FS, and they had a singular focus when they established this company. Minio was established to do one thing and one thing only, and that's object storage, high performance object storage using S3 protocol, and that was the only object for the company from the start. Fast forward 5-6 years, we are still keeping that singular focus, and that's one of the reasons why we are one of the most popular software solutions for object storage out there. We started with Kubernetes day one. We are an open source company, and our popularity from the number of Docker downloads that we have to implementations in large enterprises, it speaks for itself essentially. Software defined, we talked a lot about software defined. That's one of the other reasons why Minlo is preferred by many in the industry, because it gives you all the flexibilities that we talked about without compromising on the performance. And finally, performance. Performance is one of the cornerstones of Minlo, and we use a few different things. For example, in x86 chipset, we use something called AVX512 in order to do some of our erasure coding calculations. We are very public about it. We wrote blogs, we gave speeches about how we achieve that. We also implement the same thing for ARM chipset, as well as worked with other chipsets too. So the performance advantage we have comes from utilizing these registers within the chipset and using them to do the repeated calculations. By doing that, we achieve the CPUs being quite idle for many things, many other things, one of them being the pushing through the throughput for customer data essentially. We don't spend the CPU cycles for doing these erasure coding calculations. We literally use the registers for that, and having CPUs for throughput makes us the highest performance object storage in the market. So with that advantage, we focused on the partners that we have in the industry that we can add value and make a huge difference for our customer base. And one of the successful one has been Splunk SmartStore. So Minlo is already a high performance object store that is software only. When you take that together with SmartStore, you can achieve very high speed, large scale, and highly available implementations of SmartStore that supports any Splunk infrastructure in large enterprise. So a few different things that we've done compared to the other software object storage providers. We focused on replication across data center. This is the only solution that we know of. We are going through the certification process with Splunk currently. We have the ability to continuously synchronize data between two data centers. We have a replication that allows for active-active, so that you can have both sides checking for each other and both sides can replicate to the target with the differences that we see. We use something called bucket notifications to look for all the differences. So if you do a put into data center 1, that bucket notification process realizes that new file and then make sure that that gets replicated to the other side. So that's the first thing. That's a clear advantage when you use Minlo software together with SmartStore, Splunk SmartStore. The other piece is the metadata database. Most of the providers of object storage in the market today, they use an external database for their metadata. In Minlo, we did something different from day one. We took the metadata that is required for the object storage, the payload, and put it together with the data itself. So having that advantage and eliminating the bottleneck from an external database allow us to scale tremendously. And you have seen in the example that we talked about Box using 16 node and filling them up with hundreds of disks, and they can still add more and more as if they want to, because they will never have an external database that is listing all of the metadata and creating a bottleneck for a large implementation of an object storage solution. And finally, we have a software called Sidekick. It's simply a lightweight load balancer. It's a sidecar load balancer. Instead of using the traditional load balancer approach in front of your object storage servers, you can easily put this together with the application. In this case, Splunk SmartStore and Splunk indexers. You can put this and run it as a sidecar, and Sidekick will know exactly what's happening to the MinIO servers and will be able to skip a node that's in failure, or will be able to choose the fastest path and make sure that we are load balancing and you're not creating a single point of bottleneck with a traditional load balancer approach. So a sidecar, lightweight sidecar load balancer called Sidekick. It's a MinIO software, and it's tremendously helpful in a situation where your application, you can run it next to your application, and your application becomes S3 aware or storage aware when it comes to these nodes failing or data centers failing from one to another. So one other topic that is very important when it comes to large-scale deployments is capacity expansion. This has come with Splunk SmartStore as well as general implementations of object storage. It's a quite important area. Expansion in MinIO is done with a concept called zones, and it's a very simple concept. It's essentially a building block concept. When you start a 4-node server or a 16-node server in a large implementation, and you run out of storage over a period of a year, 6 months, a year, a 2-year time period, you need to add new hardware to expand the storage. You can create another set of storage in sets of zones. Zones allows rack awareness, and they're heterogeneous mix of hardware. So you can have buckets expand to all zones, and by this architecture, we avoid rebalancing. In most of the systems where you go for large scale, you have to add capacity, and then you have to software manually, automatically or manually by an admin, you need to rebalance for capacity. But those rebalancing always causes issues when it comes to hard disk failures and finding out things that were wrong within the system. So we eliminate totally that problem, and not having to deal with failures of disk. You can easily expand your capacity by basically running the same command that you use to set up a cluster. You just add more of the servers to the same cluster, and then MinIO software automatically expands and makes sure that it has the algorithm to use not the empty zone 2 rather than the heavily used zone 1, and then it makes sure that it balances out between zone 1 and zone 2 accordingly, depending on net new coming goes to zone 2, and make sure that it balances it out over a period of time. This is a general architecture that is talking about the active-active replication feature that we have. So this is, we talked about Box using a few pieces of the MinIO software, but this is talking about the full portfolio of MinIO software in a large enterprise, from the KES, which is a key management software. It's a tool that we have from MinIO. It's essentially when you're integrating into a KMS in large enterprises where security is very important. They tend to use a KMS system that is external to the storage system, and KES allows you to, when you grow into billions of objects, you don't want to go back and forth to the KMS system for each encryption and decryption type of operation, and KES allows you to do seamless management and distribution of secret keys at scale when it comes to MinIO. It's a step in between KMS and the MinIO system, so that you eliminate unnecessary trips back and forth to the KMS system, essentially. So in this picture, you have KES represented, you have the Splunk, a traditional Splunk implementation with indexer cluster, as well as the MinIO as the SmartStore implementation, and network connectivity between the sites is also important, depending on the amount of storage. 10 gig link to higher is probably preferred. We have a 10 gig link between the index cluster and MinIO, but as I mentioned, 25 gig is easily saturated by MinIO software, and when you're using SSD, we prefer to see 100 gigabit network connection, but that's not the reality in some shops at this time. But if you have, most people can go up to 40 gigabit as well as 2 times 25 gigabits on the storage servers as well as indexers. So that would be a preferred solution from a network perspective. We can be quite flexible. As I mentioned, our bottlenecks most of the time comes from network and secondarily from the PCI bus. When you have an SSD, a lot of SSDs can easily saturate the PCI bus, and we are as good as that configuration or the network connectivity. Of course, we talked about multi-site replication, and that's part of the solution, the attractiveness of the solution. And I mentioned we are going through the replication certification with the Splunk team currently. So to wrap up, what we have today from a takeaway perspective is, when you think big, it's important to have a SmartStore and MinIO type of a solution that is designed for large-scale deployments. Because more data means more insights for your business, and translating that, you need to really build an infrastructure that is massive. But that doesn't mean that you have to start large day one. With MinIO technology, as I mentioned, with zones, your zone 1 can be as small as 4 nodes, and then you can increase it to 8, 16, 32, however many nodes you want to grow up to day 2. Second part is think simple, because in order to build any large scale deployment, simple things scale principle is important. If you keep things simple, it's easier to deploy them, it's easier to automate them, it's easier to expand them, as we talked about, and life is easier for you when it comes to simple building blocks. In my past, I used this quite a bit because it was a large enterprise with multiple different customer bases and development groups, and everybody had a different need. I tried to consolidate into a few sizes, but then use those building blocks to build large deployments. And that's a very simple principle that should work for any system. But using Splunk SmartStore together with MinIO, we proved that it works at Box. In terms of resilience, it's also very important, because the downside of having a large-scale deployment is the risk magnifies tremendously. So in order to make sure that risk is under control, you really have to think about resilience, whether it's the network resilience with having dual cards, whether it's the number of nodes that you put into a cluster when you start, and number of disks that you provide, erasure coding configurations. All of those things needs to be considered, and as I mentioned, it magnifies the risk. And hyperscalers figure this out. It's the software-defined world, and it's proven to be true in the last 3 to 4 years, and it should be the way you approach these problems, especially when building large-scale implementations. And SmartStore and MinIO is a good example of that. When you use software-based solutions, it's easier to scale, it's easier to expand, and your life becomes easier. With that said, it's great to have you join this session, and I really would like to have you go to MinIO website, min.io, and download our software. You'll see all those simplicity principles that I talk about is proven to be true. You can just download the software and start using it in matter of minutes. It will probably take you 2 to 3 minutes just to download and start the software, and you can join the forces of Splunk SmartStore together with MinIO and do a very quick implementation in your lab, on your laptop, and make sure that you understand how they work together. And when you do so, I just want to ask you, just give us a call, reach out to me, email me, ping me, and we can just sit down and talk about how to design a very large scale smart store deployment for your enterprise, for your infrastructure. And I would love to work with you. And thank you so much for joining this session again. Great to talk to you about Minlo object storage working together with SmartStore, Splunk SmartStore. Thanks again.